All right, problem number 61 deals with comparing the volume of 1 gram of two different substances. We've got lead, very dense metal, and oxygen, which is a gas, which is by its nature not very dense at all. So for this, we're given the densities of lead, we're given the density of oxygen, and we're going to compare their volumes of 1 gram. So we're given a mass for both of them. So we're going to use the density formula and rearrange it using a little algebra to come up with the V all by itself, the volume all by itself. We find that it's mass divided by density. So for lead, we're going to do lead's calculation over here. We're going to do oxygen's calculation over here. And so volume is equal to 1 gram divided by its density. If you think back to math, a little bit of algebra, whenever we have a fraction and a fraction, which essentially is what this is, the denominator can cancel out with the numerator up here. So we're going to get our grams to go away, and our only units left are going to be centimeters cubed. And we find that our density of lead, keeping in mind significant figures, the volume of 1 gram of lead is going to be 0.8818. And our units there are going to be cubic centimeters. Let's take a look at the same thing for oxygen. Do it the same way. Volume is equal to mass divided by density. We're going to take 1 gram of oxygen and divide it by its density. 1.31 times 10 to the negative third grams per cubic centimeter. And then we do the calculations. We're going to find out that 1 gram of oxygen would actually occupy a space of 763 cubic centimeters. That's about as big as about a 20-ounce soda bottle. If you look at the volume on there, it's somewhere in the ballpark of about 750 milliliters, which is the same as a cubic centimeter. Whereas this volume over here is absolutely tiny, 8/100ths, just about 9/100ths, or maybe round that up to 1/10 of a cubic centimeter. So think about something 1/10 the size of a sugar cube, whereas we got something about the size of a Coke bottle over here. So the densities of the elements, as we're going to find out, have a very, very broad range. And that's it for number 61. All right.